Welcome to the SAS BI platform to improve use of analytics in higher education. Do the stats match the intent? My name is Sean Mulvannon. I'm a professor of educational statistics at the University of Nevada, Las Vegas. Brief background on myself. I am, as I mentioned, a professor of educational statistics. I am emphasize K-12 educational and higher educational analytics, modeling. My areas of expertise include growth modeling, hierarchical linear modeling, longitudinal data architecture, and various educational policy models. A brief bit on my background. I was a professor at the University of Arkansas for 22 years. I've been an associate dean at the University of Nevada, Las Vegas. During the last 20 plus years, I also served 3 years as the senior advisor to the Deputy Secretary of Education in Washington, D.C., where I worked on large-scale data modeling, growth modeling, and educational policy. Anyway, moving on, the emphasis of this presentation, and consistent with the title, do the statistics really match the intent? One of the various challenges that's been identified in education, and it's been going on for quite some time, is that we seem to have a lot of metrics out there that don't necessarily align with the goal of policy. For example, on the first slide with background, I have the definition persistent and completion highlighted in red. In academia in particular, in higher education, there is a tremendous amount of pressure to increase both of these. Now, persistence is a new term, a relatively new term, and it refers to students continuing to stay in school. Completion is more aligned with graduation, but completion also has a broader term that can be aligned with other program areas such as graduate certificates, technical degree programs. So it's more encompassing, but kids complete or students complete the degree programs or the technical programs that they've enrolled. Questions on metrics on how to use the key metrics. For example, I have a chart here of graduation rates and then some degrees of college. And these become really interesting metrics because when you talk about some degree of college, is that enrolling in school? Is that, to what extent, what do you mean by some? Some is a fairly omnibus word, so it can entail any number of things. It could be 1 credit hour versus 116 credit hours would fall into the same category. So the idea of some is a great example of what we mean. What are we really talking about, and how does that metric really align with the goals of persistence and completion? Persistence is also a fascinating term because what do we really mean by persistence? Presently, there is a lot of research around persistence, and it's focused on students actually completing, there's that word completing again, a single course. So they're looking at metrics that start in the beginning of a semester, look at your performance during the first 4 or 5 weeks, subsequently on an initial test, and using that information to predict the likelihood that you will or will not complete the class. Furthermore, or were successful in the class. Furthermore, what they're also doing is it's really an odd kind of classification. They do A and B as being successful and C, D, or F as being unsuccessful, but C and D count towards your graduation in most academic programs, in particular in elective courses. So just the very model by which they are defining, or the process by which they're defining persistent, becomes complicated, and from a mathematical statistician's perspective, increases the amount of measurement error associated with using both persistence and completion. Paradigm shift. I think there's a greater challenge out in higher education now where student expectations, personal responsibility, prerequisites, preparation are actually being marginalized as a key element of students being successful both in their persistence and completion, and are being replaced with greater responsibility or oversight of the post-secondary institution. So as part of that, the academic support systems, which really aren't new or paradigm shifts per se, but what they are greater expanded resources to support kids, including virtually every group on campus has their own support mechanisms, support groups. They have clinics you can go to. They have both social and academic support networks. A new invasive thing on campus they're called learning management systems. You may have heard of them. They're Blackboard, Canvas is another example, and they are these data support systems for students that are aligned with classes that allow the faculty to put course notes and a lot of other things that would normally be handed out in a traditional classroom style. But they can also put practice exams and things on these websites that will give the student greater access to information. They can also interact. So it's a much more online method. But like the version at the University of Nevada, Las Vegas, they collect over 1,200 variables. So there's a lot of information out there. But a lot of these variables are a little dubious, and I'll talk about that here in a moment. Another learning thing that's out there is blended learning models, where the perception is it's too difficult for people to get to campus and actually attend classes. And the point of attending classes is the problem. So we want to make it online where they can fit their schedules. And so you're seeing a lot of online proliferation. This has also been conflicted with, there's a lot of for-profit online corporations and things out there that also have quote-unquote accredited programs. I'm having participated in the accreditation program and actually being one of the peers for the Higher Learning Commission that accreditates universities. I know that the process is, I think if you produce enough paper and you are able to sign enough checks that you can get accredited. And I don't say that to be cynical. I just watched the process. And so the blended formats also raise some issues about really educational return on investment, which I'll talk about here in a minute also. Methods to address these new challenges. Data architecture, which is where I think SAS is such a powerful platform. Linking of data in the system. If having worked with educational data, I wrote my first SAS program in September of 1988. So I've been programming in SAS for a long time, and I like to think I wouldn't say I'm an expert, but I'm very advanced and can do a lot of things, and I can do it from scale all the way up to dissemination. And data architecture, especially with educational platforms, is very difficult for any number of reasons. But in particular, some of the vendor models are very troubling, because as soon as a vendor gets hold of educational data, the first thing you do is they strip off a unifying identifier, like, for example, the National Center for Education Statistics data structures. They will strip these things off, and they'll put in their own identifier, which precludes you from integrating their data, which they usually contractually are required to put out in a public domain, and merging it with any other data that you may have locally. And that will include stripping student IDs and student names, which is required under FERPA. But the unit of analysis, which is most important, is the school or the classroom, and that gets stripped off. And so the linking of data is really problematic. And in higher ed, we have a tremendous number of information. I know that business is very envious of the data that we have and would love to get access to it to invent products, which we don't do, which is part of also what I'm talking about with this presentation. We got to do a better job of that. And a single source solution and in particular via SAS is a really important element of this. Also, improving of the metrics. And I just spoke about this, the definitions, the computations. I refer to this as the analytics model, and the data architecture in those key pieces I refer as the elevator model. Now, when you talk about the definitions, people don't understand, and the definitions also includes data rules and how you're putting things together. So, for example, when you talk about duration, which is a common metric in the LMS or learning management systems, this data, and I talk about this in the paper, if a student attempts the practice test 3 times and does it 30 minutes the first time and gets 5 out of 10, and then does it a second time for 20 minutes and gets 7 out of 10, and then tries it a third time and takes 10 minutes and gets 9 out of 10, what the LMS system will provide you is duration of 60 minutes, which is interesting. It's a metric that you would want to use, but the 3 metrics of 30, 20, 10 are incredibly valuable, and from those 3, you can actually get the duration of 60 minutes. They also report only one score of 9 out of 10. So now I have a score of 9 out of 10, which looks great. But there was a process by which the student went from 5 to 7 to 9. That's also valued because it's a measure of engagement that is the only people that own that are the folks who own the system. They don't provide us that information as part of it. And so that part of that's out of Compass Learning too. So how we find the metrics, or even graduation rates, for example, become very important, and the data rules about how we do that and defining them are really interesting. For example, at University of Nevada, Las Vegas, a couple of years ago, they had 400 new freshman engineering students. But 100 of these students, approximately, were required to take remedial math. So these aren't your traditional engineering first-year freshmen, but they will count in your graduation rate. So the likelihood, so right away with those 100 kids, the likelihood that they're going to graduate as engineers is very low. So now really you only have 300. So the best that the engineering college can do with a graduation rate is really like 75%. And even if they get 50% of those kids, then their graduation rate is going to be 37.5%, which isn't very good, with a 48, 49% national average. So they start behind the curve. Even though they're 50% of those traditionally admitted students did pass. So the metrics are incredibly important. The data rules and the definitions become very important. And then the ability to innovate resources out of that. This next slide looks at the data elevator model. And what I'm really talking about is how you take information from that first floor and really interact with each of the succeeding floors as a model. And the data goes in, it's processed, it's kicked up, and it keeps improving as it goes to the last level, which is the ability to send out more meaningful information. I think one of the other embedded challenges is that there are a lot of people that can point and click and can develop analytics, but do the analytics make sense in the context of whatever the purported use? The validity of the analytics, I think, is a problem. Having been a professor since 1993, having been in higher ed in various ways as a graduate student since '86, and having served as a senior advisor, deputy secretary, served on numerous national committees, been associate dean, served on been director of research and assessment for 3 years at the University of Arkansas. Understanding the metrics is something that a lot of people claim, even myself, a knowledge, but we need to grow that knowledge and understanding with the examples of the graduation rate that I just shared that create a lot of problems in our ability to be more effective and improve the actual persistence in graduation rates. We started a pilot program. I actually wrote a National Science Foundation grant. It's called REBELS, and it stands for Research, Evaluation, and Building of Effective Learning Systems. So we're taking that learning management system and we're trying to develop it as a model and platform about how to really use that data more effectively, integrate it with transcript data, We're trying to integrate also high school transcript data. So we have more of like a ninth grade through completion model. And what we're really looking to do is do some innovative development pathway models about how students succeed, and some probability density functions on the margins that really show that based off of this child's educational profile, what is the likelihood they would be successful as an engineer? So those original 100 students, we're not discouraging them. We certainly want to encourage anybody if they want to be an engineer and you've had a poor educational preparation, how can we help you be better prepared? We're not trying to limit or preclude, but we need to better understand the likelihood to get better metrics and ultimately help these kids be more successful. And so we have a lot of things in our file cabinet there, and they're underutilized, or they're utilized in a way. A major goal in education is to make things so simple that they render themselves meaningless. Predictive analytics, a lot of great things we can do there with growth models, improved project models, relevance of the analytics that I've talked about. One of those relevance models is rethinking graduation rates. So I came up with this model, which I'm calling expected graduation rates. And the goal of this expected graduation rates is to really take into account the historical performance within particular colleges and the likelihood of success of those students based off their academic profile. So there could be multiple groupings, traditionally admitted, marginally admitted, and then look at those expected graduation rates. And now when I calculate the graduation rates for computer science, engineering, or any number of physics, my undergrad's nuclear physics, if you were to look at those things, then you'd have a better idea of what is reasonable. You know, when you look at the cumulative GPA in a college of educations, they're 3.5 and higher. When you look at engineering, it's between 2.5 and 3.0. So the expected graduation rate should be different relative to those two categories for colleges. Now, big data and education, man, this has been around. I was part of all this in DC. I was part of No Child Left Behind. Did a lot of accountability modeling, built a lot of systems for different state education agencies. And the policy, I wrote a book chapter, actually, it's cited in the paper, on what I'm always afraid of is people always blame either psychometrics, which I know psychometrics, or they blame statistics and testing. But the real moral of the story, the challenges that we most have are not about the mathematics and statistics per se, or the psychometrics, the test, and the process of evaluating. It's really the educational policy that lays over the top. And so if you get a chance, not to do a shameless plug, but that book chapter is actually quite illuminating as to some of the challenges and problems we have. I love this. This is a great comic. Feel free to read this at your leisure. But I love the last line by Dogbert, which says, "Okay, let's pretend that matters." When he asks, "Is the data accurate?" I was always advised by the deputy secretary that I had two goals: statistically accurate and legally defensible. That became kind of a standard, and can I really defend it? There's a lot of things out there that are almost indefensible, and so it's really important that we get back from integrity and have the analytics match the intent, because it is a challenge, and it happens in various ways. You know, in growth models, this is not growth, but legislatively, they had to have a negative decline. So if a student stayed above this line, but declined grammatically, the parents were still told that the student made adequate yearly progress. And they still do this today, even as part of ESSA. And so it's really important that we get back to the business of understanding and providing metrics that really go toward improving educational outcomes for all the students. In addition to that, we want to make sure that we build systems that can go from bottom to top, that elevator model, in a single source solution, so that we can control the domain, the analytics, and the vetting and the validity of the outcomes that are produced. And so we're working on a series of systems to do that. So anyway, those are the models. Thank you for your time today. If you have any questions, please feel free to contact me. And here's my contact information. Thank you.